form new combinations of participants in a subnetwork by dividing up sort of the larger group. And this is something that David Reed conjured up, and he calls it, people have called it now, Reed's Law. And how many people are familiar with Reed's Law? This is a very surprising network dynamic if you've never sort of played with it before. So if you go off and explore Reed's Law and start thinking about what that 2n value number looks like, you start comparing it to this broadcast model and sort of the standard one that we all talk about, which is Metcalfe's law. And Reed's value proposition is explosive. It just, you think n squared is a fast-growing function, but 2n is like rockets, right? I mean, it starts going and it just explodes on you. And this is a really powerful network dynamic if you can figure out how to tap it. And, we've had sort of demonstrations of how you can sort of think about this, right? I mean, if you think about sort of the shape of the 2n function, it sort of approximates at different points the other two, right? So as it's just getting started, it kind of has this nice linear progression that looks a little bit like n, and then it starts sort of bending upward a little bit faster, and it's starting to approximate the n squared. It's starting to take off, and then it just rockets away from the n squared, and you have this sort of 2n explosion. And so you can think about sort of different segments of evolution or different types of network dynamics, things like your standard broadcast versus email versus wow, AOL. It really sort of fell onto something. Everybody was talking about sort of the value of being a part of AOL so you could participate in the chat rooms, and that was because chat rooms allowed that network to be